Modern underground infrastructures like subways, motorway or railway tunnels increasingly use industrial drilling techniques rather than traditional methods like, for example, explosives. Drilling in this case is carried out with machines called tunnel boring machines, or TBMs. These machines are in fact underground factories which bore full-face galleries, evacuating all spoil, and which put into place the tunnel lining as it moves forward. The head of the machine is attached to a long line of logistic equipment for the running of the machine. The cutter head, situated in front of the shield, bores into the rock by turning slowly on its axes. The ground or rock gets pulled back by the cutter head and is extracted by a screw conveyor towards the rear of the machine. The front of the TBM is protected by a shield tail 7 centimeters thick, which temporarily supports ground until the tunnel lining is installed. As soon as it is bored 1.80 meters, the machine stops and installs concrete segments in the shape of a ring whose internal diameter is the final dimension of the tunnel. As soon as the concrete ring is in place, the boring can start again. The thrust cylinders apply 2,000 tons of pressure on the previous ring, pushing the cutter head forward, pulling its backup train with it, and so the cycle continues at this rhythm 24 hours a day, 7 days a week. Let's now have a closer look at the TBM production team just after work. A team is composed of around 20 people, managed by a shift boss. Each person plays an important role, so team spirit and comradeship are essential. This is the rear view of a TBM. Let's climb aboard. To get to the front of the machine, you have to go through the abdomen, 100 meters of backup equipment. The abdomen is in fact a 100-meter-long mobile factory, which provides the logistics and the autonomy of the TBM, steering, electricity, hydraulics, air, grease and grout injection. On board the TBM, teams work like submarine crew. In a confined space, accesses are narrow and getting around is not easy. It's a living as well as a working space, which, as boring continues, gets further and further away from everything, including emergency help. So hygiene and safety regulations must be followed with great care. Apart from the basic safety precautions like wearing helmets, gloves and boots, great care must be taken that accesses are not blocked, that grease drums, like all inflammable products, are carefully stocked. In other words, the TBM needs a strict set of housekeeping rules. Behind the shield tail is the nerve center of the machine, the control cabin, where technicians verify the forward progression and the type of face being bored. It is here that all the parameters of forward progression are finely tuned, as are the installation of the rings and the exact route of the tunnel. Guidance is vital, for not only does the machine have to be steered in 3 dimensions in exactly the right direction, but the clearance defined for the positioning of the segments has to be precisely followed. In order to ensure this, surveyors use a laser guiding system. After the TBM has bored 1.80 meters, it stops, so that the concrete ring composed of 6 7-ton segments and a vault key can be put into place. The segments are transported by trains onto the TBM and then positioned one by one using a vacuum erector. Here we can see just behind the cutter head in the shield. The thrust cylinders pull back to give way to new incoming segments, revealing the shield tail. The rings will be positioned inside the shield tail, which is temporarily holding the ground in place. Thus, teams can work in perfect safety. The operator will use an erector to position the segments. It's a delicate operation which demands great care and concentration, and of course, a strict adherence to safety regulations in order to avoid all possibilities of an accident. Only 35 minutes are required to position an entire ring. Elsewhere, a precast factory ensures a steady supply of concrete segments. A segment is manufactured by putting a curved steel reinforced cage into a concrete mold of a required size. The assembly line advances automatically, taking the mold into the concreting room, where it is then filled with concrete. The composition of the concrete has been specially designed to have a strength of 50 MPa and be particularly long-lasting. The concrete is subject to a strong exterior vibration to make it as compact as possible. Then the upper surface of the segment is smoothed by hand to make sure it is perfectly flat and waterproof. Maintaining an efficient production rhythm, a mold is filled every 10 minutes. As soon as they are cured, the segments are taken out of their molds, turned over, identified and fitted with neoprene gaskets capable of resisting pressures of up to 10 bar. The segments are then stocked in an outside storage area before being transported into the tunnel. As soon as they are positioned, the rings are bolted together so as to compress the gaskets and unite the segments to those already in place. If the ground is sufficiently stable and there's no risk of it caving in, work is carried out at the cutter head at atmospheric pressure in the so-called open mode. When boring into soft ground under the water table, the pressure can be as high as 2 or even 3 bar. This is when the closed mode is used. An airtight diaphragm and high-pressure seals isolate the rotating head from the rest of the machine. When the ring has been put into place, there's a space of around 10 centimeters between the ground and the ring. This space is filled by injecting back mortar grouting, which has been prepared in a mortar plant. The grout is injected through pipes in the shield tail at a rate of 12 cubic meters per ring. The TBM can move forward again. Each cylinder applies a pressure of 200 tons on the previous ring, pushing the shield forward, and at the same time pulling its 100 meters of backup equipment. At regular intervals, whenever necessary, the mobile factory deploys its cables, extends its piping system, lays down ventilation ducts or its conveyor band for the removal of muck spoil, or even lays the tracks necessary for the trains which supply the TBM with its needs. Inside the cutter head, picks and cutters are slicing into the rock face, breaking it into tiny bits thanks to the pressure of the shield. Muck spoil extracted by the screw is carried away on the conveyor band back along the existing tunnel. At the end of the line, thousands of cubic meters of spoil are poured into sedimentation tanks before being taken off the sites by lorries. Making use of a routine maintenance operation on the cutter head, we access the personnel lock, just behind the cutter head which bores into the rock face. This cutter head measures 8.75 meters in diameter. Technicians inspect each disc cutter individually to make sure they're in good condition. The rock causes considerable wear and tear on the disc cutters, and depending on the hardness and abrasiveness of the terrain, they need to be replaced more or less frequently. Worn disc cutters are replaced by hand. Each piece weighs around 150 kilos. In open mode, i.e. without pressurized air, maintenance teams work on the cutter head at atmospheric pressure. When the terrain is under pressure and the teams are working in closed mode, repair work needs to be done in hyperbaric pressure. At 20 meters below the water table, the TBM works under a pressure of 2 bar. To avoid the tunnel caving in and to ensure that teams can work in perfect safety, compressed air is blown into the cutter head at a slightly higher pressure than hydrostatic pressure. The teams can then carry out their work in this pressurized area. The teams, rather like sea divers, gain access to the cutter head by passing through a personnel lock for decompression and compression, which allows them to go from atmospheric pressure by successive stages. Working in hyperbaric pressure necessitates specialized training, often carried out in hospital training centers under medical supervision. After several months below ground, the day the team has been looking forward to finally arrives, and the TBM reaches its final destination on schedule, leaving behind it an almost completed tunnel. Soon you will be constructing a tunnel in Hong Kong with a new type of TBM, an example of international cooperation in which the experience and know-how of different partners will contribute to the success of the project.